So let's try this question. It's from the book The Art of Problem Solving. That's a lot of Olympiad styled questions. Now we have this. Q is an integer. It can be expressed as the sum of two integer squares. So let's pick A and B as those two integers. And we know that Q is the sum of their squares. Now, what do we want? We want to show that 2Q is also a sum of two squares. So what is 2Q? That will be 2A squared plus 2B squared. Now, this is not the sum of two squares. And why is that? It is because this can be written as root 2A squared plus root 2B squared. Now we can see that this is irrational, this is irrational. So you have an irrational number multiplied by an integer. You get what? You get an irrational number. So that means that it is not yet the sum of two squares. So we have to find a way to write it as the sum of two squares. And what do we do? Now we can split it up into A squared plus B squared plus A squared plus B squared. Now these are what? These are two integer squares. Now this is four integer squares. We want to write it as two integer squares. So how can we do that? Now A squared plus B squared we can write as A plus B squared minus 2AB. Now if you do the same thing for the other part, A plus B squared minus 2AB. How can we leave it this way? No, because we want sum of two integer squares. That means only the square parts should be left. Only the square parts should be left. So what can we do so that we have only the square parts? We change this to a minus and this becomes a plus. Now if we do that, what can you notice? Minus 2AB knocks out plus 2AB, so that we are left with A plus B squared plus A minus B squared. Now since A and B and it are integers, we are sure that A plus B will also be an integer and A minus B will also be an integer. Since there is no way you add or subtract two integers and you won't get integers, it's impossible. It's not possible. So we have successfully done the first part. Now the second part is 5Q. Now 5Q is 5A squared plus 5B squared. Now what do? We split it up into two parts or four parts, just like the previous one. But there's going to be a problem. The four parts we are splitting it into, we have to be careful that when we write them as squares, the first part must be a square, the second part must be a square, and these product terms, they cancel out. They must cancel out. Okay? So if we want them to be squares, we have to make them, when we are writing them, we have to write them with perfect squares as coefficients. Because you can see from here that this is one of these and one of these. One is a perfect square. It wasn't obvious until Now that we needed to do a more complicated one. That means that I can do something like 4a squared plus 4b squared plus a squared plus b squared, right? So what am I doing? I'm splitting up into perfect squares, something like this: 4a squared plus b squared plus 1a squared plus b squared. Okay, now can I do what I did previously? No. Why? Because if I try to do that here, the product that will result from here will be 4 times 2, which is 8. What will result from here is 1 times 2, which is 2. There is no way in this world to make 8 and 2 cancel out. It won't work, because look at what we are having. We have 1 times 2. That's why it is 2ab. And we have 1 also times 2 from here, which is also 2ab. So we have to make sure that the products cancel out. So what are we going to do? We are going to have to rearrange. And when we rearrange, we can do 4a squared plus 4b squared plus a squared plus b squared. Now we have not arranged, I just expanded the bracket. Now this is the same as 4a squared plus b squared plus a squared plus 4b squared. Now you can see that this is 2a squared plus b squared, and this is a squared plus 2b squared. Now what do we do next? Now we have what we want, because 2 times 1 is 2, then times 2 is 4, and we have exactly the same thing here. So what do? We say this is 2a plus b all squared minus twice of the product, right? So the product is what? 2a and b. Then plus the other part. Because we want them to cancel out, we write it opposite. A squared, or a minus 2b squared, plus twice of the product, a and 2b. Now this is going to give 2a plus b squared minus 4ab plus a minus 2b squared plus 4ab. Now can you see how beautiful this has turned out? Minus 4ab plus 4ab, they knock out each other, and we are left with 2a plus b all squared plus a minus 2b all squared. This is 5q. Now can you see that we have written 5q as the sum of the squares of two integers? Because since a and b are integers, 2a plus b will be an integer, and a minus 2b will also be an integer. And this successfully completes the proof. So see you another time.